Hello everyone, welcome to my channel. In today's video, we're going to talk about three MDX functions, which are Ancestor, Ancestors, and Ascendants. All these three functions more or less work like a similar pattern, but let's get into the details. Ancestor is nothing but if you take it normal terminology, and if we consider that our family hierarchy. So if you refer me, that I choose the current member, and my ancestors will be like my parents and their parents and grandparents and grand grandparents. All these are they are our ancestors. It's like a backward direction from whatever the member that you refer from there will go back to the left direction, which is the upward direction. So whatever the family hierarchy that we refer, we call it like ancestor, whoever born and lived before us. And even ascendants also, it will be like our family hierarchy. You take it, you go back to your parents, grandparents, and grand grandparents. So like that, we'll have the family hierarchy, right? So similarly, in OLAP queue, our data will be stored in the same way. Let's say you have the product. So product is your lowest granularity. On top of the product, we'll have a subcategory. Subcategory will be like a ancestor to product. And similarly, on top of subcategory, you will have a category. So for the subcategory, the ancestor will be the category, right? So that's how the hierarchy built in queue to bring the data. So we'll use these three functions for different scenarios. Most of the time, ancestor and ancestors, where we can control and we can mention which level of ancestor information that we are looking for. And then ascendants is like it's a default behavior. So whatever the chosen member or chosen level member, from there it will go back to the upward direction, bring entire data. So let's get into in some details with examples. Let me first go to the ancestor. That is the function that we take some examples, try to understand. But before we go into that, I want to pay attention on the right side. And here I just fetch the internet sales for the category level and subcategory level, because while I'm explaining to show the results, how the results are behaving, it's easy for me to explain. That's the reason I'm just displaying the results on the right side. So this window will stay until we complete the video to explain you a more detailed way. Now coming to our left side, this is where we have the ancestor function. Within the ancestor function, we'll have two types of ancestor function. One way where we can mention the level of the hierarchy. What is the level that you are looking for, category level or subcategory level or product level. So whatever the dimension attribute level that we map it in the function. Or you can mention the distance. Distance is nothing but the distance between the hierarchies. What is the category, subcategory, product. So if you take it, the product is the 0, that is your 0 is your first distance, and then subcategory will be 1. So the distance between 0 to 1, it will be 1, right? And similarly, category will be your 2. It's like more or like that you mentioned uh, what is the your hierarchy level that you want to mention it and bring the data. So let's get into the details, how you can use the ancestor function in your some scenarios. And here you can look here. First, what I'm trying to do in this query, I wrote the MDX query where I'm trying to fetch the internet sales for the category level. That is my ancestor that I'm looking, category level ancestor, whatever the member that I specified in my select statement. In my select statement, I choose my category level information, right? So the category 4, that is my accessories information, and then the respective ancestor information I'm trying to fetch it. So for accessories, the ancestor will be nothing, because we are at the category level, right? On top of the category, the next level will be all our products. But now what will happen, here along with our category 4, I'm fetching the information at subcategory level. Now the reference point will be subcategory for ancestor function. So on top of the subcategory, the immediate ancestor will be the category. Now what will happen, the functionality, it will take the reference of the subcategory. For that subcategory, it will take the accessories information. So under the accessories 4, all it will fetch the subcategory level information. But for since the lowest granularity that we used in our select query is subcategory, it will bring the category level information, which is the accessories information. So that accessories level information, whatever we have internet sales, you can refer here right side. For accessories alone, the internet sales amount is 700k. That amount will be mapped to the calculated member X, and it get displayed on the um, under the select result, because we mentioned in the select column, and it's displaying the, I mean, it's repeated the value for all the subcategories, but this value is at category level. So that's how the ancestor behaves. So the chosen member, whatever the member that we chose, and then whatever the distance that we mention, for the distance it will bring the value. So here our distance will be the product category, right? So that's how the ancestor works. Now coming to the level. So using the level in the ancestor function. Now in here what I'm doing, I just fetch the data. Again, here I'm trying to take the bikes information and subcategory level. That's what I want to display in the results. But in the with member for ancestor function, I want to take the level 1 information. So again, level 1 information is nothing but our first level in our hierarchy. Let's say you have a product category hierarchy, right? Under that, you have the first level will be your category, will be your first level hierarchy. So now what happens? So since I mentioned level 1, it fetches the grand total of the bikes information, right? So that's how it will fetch the data. Now if I change this to 2, now the 2 will be subcategory. So now what will happen, we'll get the subcategory level information. Now let me execute this, and you can see here for this 2, sorry, it's not subcategory. Yeah, it's going back actually, 1 and 2, right? So ancestry is always go back, right? So for this subcategory, the next level is the grand total. Okay, so previously it was 1, that will be our bikes is our you know first level. But if you go back to the second level, mention the second level, that will be all products will be the our next level. So now it will fetch the grand total of all category information, all products information. Now if I mention 3, so on top of all products we don't have anything, then what will happen, you will get the empty records. There is a null records that you get it. Okay, so that's how the ancestor works with the level function and distance. Even if you can see here, even I mentioned the 0 is our level. 0 level is nothing but subcategory is our lowest granularity that we choose in our select statement. So that means subcategory is our 0 level within our query. Now it fetched the grand total for the subcategory level. So that's about the ancestor function, and these are the some examples. And moving on, here what I'm doing, here also I'm trying to use the ancestor in select statement instead of the with member. Now what will happen, let's see with some examples. Now here what I'm trying to fetch, so I want to second subcategory information, that is the level that I choose, and this is the subcategory 2 is nothing but our road bikes. Okay, and then I choose for the 0 is nothing but same level, subcategory is my chosen level, and the 0 is the same level. And if you look at road bikes, the grand total, that is what we are getting. If I change this to 1, so what will be 1 for the subcategory, it will be the category. So now the expectation will get the entire bikes grand total, which is the 28,318. Let's see what we get it. Okay, so here you can see 28,318. If I choose 2, then again we'll get the all products information. Now let me execute this and trying to fetch it. So now you can see we get the all products information. Even the similar case for the this query here, instead of level I use the distance, where I mentioned the what is my distance name, that is my dimension attribute column name. So now here I'm trying to fetch the product 311, so which is a road bikes, part of the road bikes. Since it's part of the road bikes, for this product 311, the immediate ancestor will be the road bikes, and it brought the grand total of the road bikes. So remember that it's not fetching the 311 product details. Instead of that, it's fetching the whatever the ancestor for this 311, the respective subcategory information we are fetching. So the road bikes is the immediate ancestor for this 311. That's the reason it brought the grand total for this particular subcategory. Even if you change this to category, yes, you will get the grand total of your category. Let me post the category here and execute. Now you can see here we get all the bikes information, and even if that's how the ancestor works. Okay, and moving on, we're going to talk about the ancestors function. Ancestors is more or less work like same way like ancestor. Even if you look at the syntax of the ancestor, it will be the same, where it will take the specified member and then distance and level. Now what will happen, ancestors, it will bring the set of the ancestors details, but actually in cube, if you take it any scenario, one member is always will have the one ancestor, right? Let's say you take the product number 311, right? So 311 is always willing have the road bikes. It's always mapped to the road bikes, and road bikes is mapped to the bikes. So always we'll have a one-to-one relationship between the one attribute to another attribute in hierarchy. But there are the scenarios where what will happen, you might have the unknown values within your each level. Let's say you have a category and subcategory. Under subcategory, you will have a subcategory. Okay, so if you take the category under the subcategory, each subcategory will have an unknown member value at the product level, right? So now the unknown member is part of the all subcategories. Now when you use that, when you're trying to fetch the unknown bucket, whatever the unknown member is, part of the whichever the categories, then you can use the ancestors. Ancestors will help you to bring the unknown member is actually there at the product level for each subcategory. Now we want to see that which categories are having the unknown member at subcategory level. That scenario, you can use the ancestors. But presently, I don't have unknown values at subcategory level. So just I'm telling that where exactly the ancestors will help you. That is the place you will get that details easily, and ancestors will be helpful to fetch the data. And the other thing is, you can also ancestors will more or less, as I mentioned, right, apart from fetching the unknown member value, so the ancestors will work like ancestor. Now let's fetch some examples here. So here in the first query, what I'm doing, using the ancestor, I'm trying to fetch the uh, product categories and then current member value. So where I choose the level 2. So now I'm in the select statement, I used my product level information. Now let's see what will happen. So you can see here the mountain 100 silver 30. That is the product that I chose, and I'm trying to fetch the level 2 information. It's not picking up. So because the ancestors are not helping to use along with the member. Just I'm trying to show you the error because ancestor cannot be used in the calculated member. So it can be used in your select statement, but ancestor can be used in your calculated member to perform some, grand total of the any specified current member. That is the one another difference between the ancestor and ancestor. Now, but apart from that, if you execute this particular query, so the ancestors will bring the information. So 311 is actually, it's part of your role. I think it's zero, right? Yeah. Since I'm using the zero level, it's about the internet sales for the 311 product. Okay. And even here, if I'm trying to fetch the same thing, here I mentioned the level, but here I mentioned the distance. Okay. We have two types of ancestor function, right? Level and distance. So here 0 is my level, and here the product is my distance. Okay. And both are giving the same results. Even that's expectation, both will fetch the same results. You can see here. Let me pull it up. So yeah, I can see here. And now coming to this function, I just use the nested function. So within the ancestors, I use the ancestor, and again I'm playing with that. So just I'm trying to show you it's possible to do the nested queries. What I'm doing here, so 311 my belongs to my road bikes, and here what I'm trying to fetch. So I want to fetch the 311 and their ancestor information at subcategory level. So which is my road bike is the ancestor. Now since I use the subcategory, it would alter road bikes internet sales amount. For example, if I change this to category, the outer ancestors query, not inner one, then this time it will fetch the data for entire bikes. Okay, so entire the bike sales is 28,318,144. So that's how the ancestors and ancestor can be worked in the nested way. But again, as I mentioned previously, so ancestors will use when you have the one specified member is part of the multiple hierarchies. Okay, those scenarios we can use the ancestors to fetch entire information. So moving on, we're going to talk about the ascendants. Ascendants function is actually the syntax. If you look at here, for specified member, it will go back to the upward direction and bring entire ascendants information. Let's say I choose here product level granularity, where I'm trying to fetch the 311 is my product level information. Now I'm asking to fetch the ascendants of the my product 311. So now you see the magic. So now the uh, for this 311 product, the ascendants will be road bikes and all products. The beauty of this function is it will also include the specified member that we mentioned on the ascendants. It's like it will use the self level that will be the specified number in our select query, and then the immediate upward all the ancestors details. That's how the ascendants work. Okay, so I mean, apart from this, there is nothing much to say about the ascendants. It's a purely used to fetch the information for specified member and then respective ancestor details, whatever the hierarchy. Now in our scenario, we have only road bikes and bikes. If you have it like that, if you have another 10 levels, it will fetch all those 10 levels information. So that's how the ascendants work. And that's about these three functions. And then I'll post these all the queries, the sample queries that I used during the video in my comment section. Feel free to message me in the comment section if you have any further doubts. And that's all for this video, and I'll see you in the next video. Thank you.